Hello, sixth grade. Our objective today is I can understand that a letter represents one number in an expression. This is like the very beginning of algebra, because we're going to start seeing more and more letters in math. We're also going to be drawing in our notes a little bit. So for example 1, I need you to draw this square, divide it up like I did into 9 sections. And we're going to answer some questions about this square. First of all, what is the length of one side of this square? The length, I don't know if it's feet, meters, centimeters, millimeters, miles, so we're just going to say units. How many units long is one side of this? 1, 2, 3. So our answer is 3 units. And since this is a square, it's going to be 3 units on every side. Okay, so the next question says, what's the formula for the area of a square? That means, how do you find the area of a square? Well, you would do area equals length times width, or side times side, since all the sides are the same. You could say side times side, and if we want to write that like a mathematician, we could say area equals side squared, so to the power of 2. Okay, so the next question about our square is, what is the square's area as a multiplication expression? So if I write an expression, there can be no equal sign, but I know area is going to be side times side, right, or side squared. So my unit that I'm using here is 3. So this would be 3 times 3. Since it's an expression, remember they don't want an equal sign. And if I wanted to be even more specific, I could say, that was an arrow, I could say 3 units times 3 units. Okay? And we're almost done with this square. So the next question is, what is the square's area? Well, what's 3 times 3? 9. And then we'd say units squared. So we can count the units. However, if we're given a different square, look at this square. We see that its side length is 23 centimeters. And that's just too many units to draw, right? I'm not going to draw 23 lines and 23 lines this way. That would be teeny tiny, and we'd probably get the answer wrong. So I can use the expressions that we were practicing up here to find the area of the square. That looks like this. So I know it's side times side. I'm going to be doing 23 times 23. And they asked for an expression, so no equal sign. And what's the area of the square? Well, we could do 23 times 23. We would get 529 centimeters squared. And since I know the unit is centimeters, I have to say centimeters. All right, so I'm going to give you different squares now, and I want you to draw both of these. So on this square, you can see the side equals 4 units, and on this one, the side is 25 inches. You might be given problems where they ask you to fill in a chart or a table that will help you analyze the squares or find areas of the squares. So for each square, they want you to fill in these questions. The length of one side. So I'm going to start with this one. The length of its side is 4 units. So I'm just going to write 4 units. The square's area written as an expression. Okay, well that's going to be side times side. So 4 units times 4 units. And then the square's area written as a number. 4 times 4 is 16 units squared. Awesome. So now let's do it for the second square. So the length of one side is 25 inches. The expression would be 25 inches times 25 inches. And then the area, if I multiplied that out, would be 625 inches squared. And remember, we put that little 2, the little exponent, because it's showing us that we just multiplied in 2 dimensions, like length times width or base times height. When we use volume, it's a 3, but for area, we write the 2. Okay, so just make sure, double check yours, that you wrote the units correctly. And we're going to move on to another example. So on this side, we kind of explored area, writing the expressions out, analyzing our squares. And this is what the rest of our notes will look like once we're done. But we're going to start with example 2 up here. You get to draw a couple more pictures. So go ahead and draw those. And so now we are going to answer some more questions about these. So this first rectangle is what we're going to be looking at, and you can see that one side says 8 centimeters, but this side is just labeled B, or B centimeters. Okay, so what does the letter B represent in that rectangle? B is equal to 8. And we know that because on rectangles, the opposite sides are equal. So this side is the same length as this side. And then this side would be the same length as this side here. Okay, so then let's look at this rectangle. Sometimes they'll give you problems where they'll ask you to identify what is the letter. What does the letter represent? What's the missing side? So this rectangle looks a little bit different. I'll zoom in a little. So the second rectangle is divided into 4 equal parts. We can see that. We know that this part from here to here is 4 centimeters. So what does the X represent? Well, I know if these are 4 equal parts, the width of each one of these congruent little mini rectangles will be the same. So this will be 4, this will be 4 centimeters, and this will be 4. So 2 of these together from here to here will be 4 plus 4 is 8. So X is equal to 8 centimeters. If we wanted to find the total length, we could do 4 plus 4 plus 4 plus 4, or 4 times 4. Or we could even do 4 plus this 8 plus this 4. So the total length would be 16 centimeters. Okay. So now we're going to move on to exercise 2, which is kind of similar to what we were just doing with example 2. So zoom back out. So exercise 2, draw these. That's pretty much as divided up as we want to get on pictures where we have to make units. So we have a rectangle that's a 32 meter by 46 meter. And then we have this rectangle over here is 1, 2, 3, 4 units by 1, 2, 3, 4, 5, 6, 7 units. And we're going to analyze those rectangles and figure out the area using a little chart. So for your chart, you need to set up a space to write the length of the rectangle, the width of the rectangle, the area as an expression, and then finally the area. So let's start with this one. The length of the rectangle is 46 M. And the width is 32 M. And if I were to write that as an expression, no equal sign, I would say 46 times 32. I might even say 46m times 32m and include my units in there. And then if I actually multiply that, I get 1,472 meters squared. For the second rectangle, where they give us plain units, I could say this is 7 units long by 4 units wide. And if I were to write that as an expression, I would say 7 units by, or times 4 units, no equal sign. If this said equation, then we could write the equal sign. And then the area would be 28 units squared. Okay? So you might see some problems like that. And then example 3, we're gonna look at volume, just a little sneak peek of volume. So you have to draw 3D rectangular prisms. So here I labeled the length, width, and height with L, W, and H. On this one we have a length of 6, a width of 2, and a height of 8 centimeters is our unit. Okay, so we know that the L represents the length of the rectangular prism, we know that the W represents the width of the rectangular prism, and that the H represents the height. And in the second rectangular prism, it's an exact copy of this one, but we just replaced the letters or substituted the letters with numbers. So we have a chart that we're going to use to analyze some rectangles like this in a second. But what you need to see before you do that is that if we know the formula for finding volume, volume equals length times width times height, then using that logic, we should be able to find the volume of this because we know the numbers to plug in now. So the length is 6, the width is 2, and the height is 8. If we multiply that, we could find the volume. Sometimes they might give you only like the length and width and maybe the total volume, and you have to find the height. When we talk about plugging numbers in for the letters, we would say substituting. That's like the fancy algebra related word, is we would say substitute. That means plug in the numbers. Okay? So for the very last exercise, you're going to have 2 more pictures to draw. Mine are a little squished, so hopefully in your notebook you have a little bit more room than this. But this first rectangular prism, we have the length across the front of 12, the width of 5, and then the height of 15. And down here is my second one. The height across the bottom, because this is kind of turned on its side, is 23, and then the width is 4, and the length is 7. And we have one more chart to fill in. So we have the length, width, height, and then the volume as an expression, and volume. We'll start with this top one. So we can fill in our length, width, and height. Okay, so let's say 12 units, 5 units, 15 units. The expression would be 12 units times 5 units times 15 units. And if we multiplied that, it would be 900 units cubed. So now that it's volume, we have a 3, or we could say 900 cubic units. And for our second rectangle, we're going to fill in the length, width, and height. So I have 23 centimeters, I have 4 centimeters, and 7 centimeters. So that means we're going to do 23 times 4 times 7. You could even write 23 centimeters times 4 centimeters times 7 centimeters. And when we multiply that, 2 numbers at a time, we get 644 centimeters cubed, or we could say 644 cubic centimeters. All right, so for your closing, you have 2 little mini questions. How many numbers are represented by one letter in an expression? And when that number replaces the letter, the expression can be evaluated to what? So go ahead and write your answers, and then you can unpause to check what the actual answers are. So I'm going to write the actual answers now. 1 and 1 number. All right. Thanks so much.